grant or wants to give us a grant to upgrade our technology in our classrooms. So we'll see. That's what Dr. Clausen was in here yesterday. I'm like, I'm not Mrs. Christensen. I don't know. Please talk to someone who knows what they're talking about. But it would be cool if we're able to figure out a much better system for recording lectures. He said something about live stream. I'm like, why? It's okay. Which of these would you guys say was the hardest one?
77.
77? How many of you guys would agree with that? Let me see, just real quick.
Wow.
Who thinks 78 is the hardest? 79? 80? Okay. So we'll see if you guys are true, if you're right, or if any of them tricked you. Number 77. We have an HA at y equals 10. By definition, doesn't that mean the limit as I go to infinity needs to be, these are rough, yeah? Because letter A says the y value is undefined. Letter B says the value as I go towards 10 is infinity. As x goes towards 10, isn't that y equals 10? Yeah. Letter C is the limit as x goes to positive infinity is 10. And letter D says the y's can never be 10. Ugh. Why am I going to, real quick, just say, yeah, no way. What's that one talking about? What would exist at x equals 10 according to letter B? A vertical asymptote, right? And this is a horizontal asymptote, so that has nothing, one doesn't have to do with the other. Forget that. Letter A says the y value at x equals 10. Once again, does x equal 10 have anything to do with this? Okay, forget letter A. So now we're down to C or D. C says the limit as x goes to infinity is 10 of a function, and then D says the y's cannot be 10. What'd you guys say? C is the best answer, and to be honest, I still don't like C technically because I could come up with an example where C is false, but that's okay. It does say for x greater than or equal to 0. Oh, okay, never mind. It said for x greater than or equal to 0, which meant that I had to be going to positive infinity. Okay, never mind. Yeah, letter C must be true. But some of you weren't totally on like a bad course if you were thinking letter D, because you're thinking vertical asymptote. And what's true about a vertical asymptote? What can a function never do? Can never cross it, can never touch it, can never hit it. There's like a silly Lord of the Rings meme with Gandalf being like, thou shalt not pass. And it's vertical asymptote. I don't know. Vertical asymptote cannot be hit, cannot be touched, cannot be accessed. So vertical asymptote, yeah, the y value would be undefined if there was a vertical asymptote at x equals 10. But once again, these were x's, we're talking about y's. But with the horizontal asymptote, it's possible to have a horizontal asymptote where the function does cross it somewhere. Does that kind of make sense? Yeah. So the horizontal asymptote doesn't actually care about everything that's going on, the entire domain. All that it cares about is going to one direction and or the other direction. Is the graph finally stabilizing? There are also ones where you have sinusoidal curves that are like getting lower and lower and lower and lower and lower. And they are converging. There is a horizontal asymptote, but it's so weird because it crosses over it again and again and again and again and again. So I know that it's called an asymptote, and in your minds it's like, okay, closer and closer, never touching. Yes, for vertical asymptote. No for horizontal. So that was a tricky one for sure. I thought that was, I don't know about the most tricky, but 77 could have been tricky. Number 78, what is the horizontal asymptote of?
The graph. The
graph of the function. If you look just right here, you would say none. Like, oh, look, top wins. But the problem is, where was the champion? Yeah, he was over at the other side, which is kind of awkward as far as order, but that's okay. They can do that. So the final answer should have been?
Keep your secrets.
Right? Oh, yes. Because it was a tie, so the ratio of leading coefficients. You could do check the signs, but they didn't say which infinity. So if I plug in a positive, it would stay positive, be a negative, which would be a negative 1/5. If I plug in a negative, that'd be a negative, and a positive would be a negative 1/5. So it didn't actually matter either way. Number 79, you're going to infinity, and what do you guys think? Top wins, bottom wins, tie?
Tie.
Oh, I heard of that.
Tie.
Tie. There you go. Yes. And then the food. Patsy. But coming back. Tie because the square root of a quadratic is a linear, so 4/1. However, was it a positive 4 or a negative 4? You're lucky they didn't have another option. But did you guys think to check the sign?
Yes.
What would have been the answer if they had you going to negative infinity?
-1.
But do you see why, or are you just guessing what I'm going?
No, I see why. Because
Why?
Because whenever you square root a square.
Square root of square, it's going to be a
Also.
positive, right? But when you plug in a negative infinity, right? So even though going to positive infinity was a positive 4, going to negative infinity would have been a negative 4. Just be careful. Check the sign. I put it there for a reason. And then number 80. All right, yeah, he was a beast. I totally agree. Let's zoom in on him because he has a lot of different things. They give us a piecewise function. And what kind of piecewise? Above, below, or not equal to, equal to? Not equal to, equal to. So let's see what's going on. Ooh, can I make him any bigger? Maybe I can. No? No? Well, that's a struggle. All right, well, the only way to zoom in, I guess I could do that. No, that's not going to work either. How about that? Okay. For number 80, it gives us the following. Piecewise function of, it's a rational function with a top and a bottom. Unable to be at -2 or 4. At x equals 4, they filled in the point. So right away, this kind of makes me think that it might be one of these guys. Does that make sense, guys?
Yeah.
So it's like everywhere but this point, this is going on. And then at this point, okay, fine, they filled it. That's kind of what makes me ponder or think about. There's this other guy, though, -2. He's not being addressed. Maybe we should look and see what's going on at -2 and at 4. So for the original function, if I was to take the limit, because you could start looking at these, but I'll give you a hint. If you start looking at them, some of them are going to look awful nice as to being true when they're actually not. Or some of them are going to look awfully similar to something that's false, but maybe it's actually true. So I like to think about it first and then come look at my options, but that's just me. Maybe you disagree. I'm going to have the limit as x goes to -2 of my f of x, and I'm going to have the limit as x goes to 4. But for both of these guys, what piece am I looking at, the top or the bottom? Bottom, you would think limit. I need to plug in, right? But hold on. Are we doing the approach or are we doing the at? We're doing the approach for limit. So if I was a little below or above the -2, I'm here. A little bit below or above the 4, I'm here. Remember, the at 4 is a trick, is a plugging in for normal functions, but not piecewises. Piecewises, I have to think below and above. So for -2, if I plug in, has anybody done that yet? That would be 4 minus 32 minus 8. Ooh. Isn't that going to be number over 0, guys? Doesn't that mean there's a vertical asymptote?
Yeah.
At x equals -2. So why didn't they fill the hole? Because there wasn't a hole. It's one of those awful ones. Now I could figure out the infinities if I need to, but for right now, whatever. He's a vertical asymptote, so I have some sort of infinity. I could check the sign, but for right now, we'll get back to it if we need to. How about for 4 though? What would have been easier, because some of you are not mental mathers, what would have been easier than doing what I just did with the -2 and having to actually plug everything in? Yeah, what if they factored it? Did you guys figure out on the bottom, you would have x plus 2 and x minus 4? On top, might have been a little bit nastier. Can we factor it? Yeah. I think. How about 8 and 4, right? So what is 4 without us even having to figure out what 4 squared plus 4 times 4 minus 32 is? He's a whole, right? He's a 0 over 0. So I can go ahead and say, all right, he's a 0 over 0, which means I have a whole. And what would the limit be? Plug him in, 12 over 6, which is 2. Okay, now let's check it out. What is true? F is not continuous. Why is that a for sure true?
Because it's a hole.
Well, but hold on. Can't holes be filled? Did they fill it properly? Oh, remember the approach has to equal the at. You see it? So the limit has to equal the point. And f of 4 is 8. F of 4 is 8. So 8 does not equal 2. Yeah, no, that does not match up. Number 2. The limit as x goes to infinity of f of x is 4. No, it's not. It's 2. Oh, wait. I'm not going to 4. Where am I going? Infinity. So going to infinity, isn't this guy everything but? So if I go to 10 and 100 and 1,000, it's that dude. Top wins, bottom wins, tie. Tie, but what's the ratio of leading coefficients?
1.
Not 4. What? No. They were smoking something. How about number 3? X equals 4 is a vertical asymptote.
No.
No! Look, it's a hole. It's a 0 over 0. That's easy. Final answer is... Okay, maybe it wasn't easy, but does it make sense now? Does it make sense? 4 was a discontinuity, or 4 was a domain problem. If you had just plugged in, it's a 0 over 0. You can always tell the difference between vertical asymptotes and holes based on what happens when you plug in the numerator, right? They're both zeros down here. What happens up there? Are these all things you're going to be studying for the test on Thursday?
Yeah.
Of course. Hope so. Let's go grade section 1.6. Let's go grade section 1.6. As you guys switch over to homework number 6 in your homework spiral, I did just post in your Google Classroom if some of you guys are like, psh, I aced this homework, I barely need to grade. P.S. Still grade. So I collect it on test day. I can't tell that you graded unless you show me something like a -0 or you write yourself an affirming note to say good job, self. Or put little check marks on all the ones you got right.
Wait, why are there 2?
However, I did also post in your Google Classroom, if you have your phone handy and you're going to use it in responsible ways, you can grab it out. I posted your test review, which you could be writing down and getting ready in your homework spiral. If you get bored at any point in time with us going over homework questions. There are also 1, 2, 3, 4, 5 books up here. And I don't think there are necessarily 5 of you that should be bored as we grade homework. But if you want to come up and grab a book at any point in time, there are a few kids last year that would come grab one and start working on the review because homework questions lasted longer than they needed them to, and that's okay. Section 1.6. Where are we at? Number 2 is C, yeah? Number 4 is A, and number 6 is E. C-A-E. C-A-E. If I were you, I would have been looking at vertical asymptotes and horizontal asymptotes. The book walks through it, but C and then A and then E. Did you guys see anything in homework like this number 4 where they like split up functions and made it all weird?
Yes.
What could you have done? What could you have done to consider it all at once instead of 2 separate pieces? Wait. Don't we have a flip book?
Oh, yeah.
Okay. Hold on. For something like number 4, because I had some people asking me questions on it yesterday in calculus, isn't it something where in the basic rules, aren't we allowed to split up additions and take them piece by piece? And if we're able, now if it's like infinity minus infinity, we're in trouble because which infinity is stronger? Would this one win? So positive infinity, would that one win? So negative infinity, would they tie? And so it might be a constant. So if it's something where you can't quite tell what the addition is, yeah, it's tricky. It's sticky and it technically kind of fails the basic rule. But this one wouldn't necessarily fail as I was going to infinity. Because the limit as I went to infinity of 2 is just 2. Limit of any constant is just itself. And then, doesn't the bottom win if I was going to infinity? So this would be 0. 2 plus 0 is 2. Haha, I could do it piece by piece, but what's the other way I could do it? If you don't like it written like this, what else could you do? What did I just do?
Multiply.
Common denominator, right? And I multiply top and bottom, and then I put it all together was one nice big old fraction. And then some of you, it would be a lot easier to look at it this way and say, oh yeah, duh, degree tied, haha, 2. So you could think about it piece by piece, or you could, sometimes it's safer to put it all together in one nice rational function. Anyway, I wasn't super worried about you guys getting stuck on the matching, even though you might have. But I know this showed up again in homework, yeah?
Yeah.
Number 10. Well, this is really pixelated. Let me get up. No, it's not much better, but that's okay. Number 10. You were supposed to fill into a table, but hopefully you saw it was getting closer and closer to 0, it being the limit as x goes to infinity. You could have graphed and seen your horizontal asymptote. This is a function where it's not going to pass y equals 0. There is no weird oscillation going on, but remember, sometimes it can, just this function will not. Limit is 0. Is that good? Number 14, now you started doing some things analytically, right? Number 14, A is negative infinity, B is negative 4. Sometimes it gets messy, so I just want to draw your attention real quick to the answer. A is negative infinity, B is negative 4, C is 0. Yes, there's work behind it. Number 24, final answer is 1/2. 24, final answer is 1/2. Number 28, final answer was positive infinity. Number 28, final answer was positive infinity.
If we put just like does not exist on the text.
The textbook wouldn't mind, but your test will. Does that make sense?
Yeah.
Be careful. Number 36 is 1. Although they go into this crazy thing called the squeeze theorem, talk to a BC kid if you want like a long version. But basically, if we're looking at sine or cosine, basically we can do a shortcut version, and this might be something good to do in a colored pen. Because it's good to grade to study what was done in colored pens on your homework before a test. Cosine and sine are really weak. Not as weak as like e to the x as you go to negative infinity. Not that weak, because that goes closer and closer and closer to 0. But besides that, cosine and sine are one of the weakest guys out there because they're always stuck going between what?
2.
No. How high and how low does cosine and sine go?
1.
1 and negative 1, right?
Between 2 halves.
So they're forever making up their mind whether they want to go between negative 1 or 1. So they're always stuck, whereas anybody else, any other function, any other polynomial is going to be going to some sort of infinity. So even though you're like, I didn't know who wins or who won as far as the champion of cosine and x, for here on out, cosine and sine going to infinity, they're always one of the weakest dudes. We can almost call them the weakest, but once again, e to the x goes to 0, so he's kind of weaker, but only as you go to negative infinity. So cosine and sine always stuck between negative 1 to 1. Because they're always stuck between negative 1 to 1, while this bottom guy goes to infinity, the bottom wins, basically, long story short. You can almost just write this down for cosine and sine and be like, oh, hey, self, remember, cosine and sine will always lose as I go to infinity. If you're curious how they went from here to here, they basically just distributed this division, because division by x is like multiplication by 1 over x. So they did it to both. X over x became a 1, and then cosine of x over x became 0. We could have also done degree test and been like, who's the champion? Who's stronger, x or cosine? Psh, x all the way. Tie, ratio of the leading coefficients is 1. Number 44 is 4. Number 48 had, did you get both horizontal asymptotes? There was plus or minus 3 halves, because if you go to positive or negative infinity, the sign changes. So the ratio of leading coefficients was 3 halves, but there were 2 of them. I would make a star. This is one of the ways the AP loves to trick you. If you just go for it real quick, you would say, there's 1, I got it, and you'd circle it, instead of realizing, oh, there were 2.
Dun, dun, dun.
Dun, dun, dun. Is that it?
Yeah.
That's
The rest
awkwardly
are
blank.
all.
Okay. I think if I keep, oh, no, maybe not. There we go. What do you guys see down here? Now I'm going to go ahead and go in Google Classroom and show you where else the review is and show what I posted. This is the book review. Now I do give you a couple different things in calculus, which is a little different than pre-cal. Mr. Che and I did basically the same homeworks for the most part. So I know that our reviews were really similar as well. For me, in my class, you do not need to write directions or problems on test reviews. I'm just saying get in there and get practice done and grade it, kind of like we do in class as far as the warm-ups. Treat it like a quiz and go for it. What am I looking for? Google Classroom. So that's one thing. That's kind of just to save you time and also just let you kind of like boom, 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 bust out practice problems. But I posted 2 different things in your Google Classroom this morning, so let's check them both out. Some of you already have and some of you haven't. The first one that I gave you was the, ooh, there are 2 of them. This is the book review, the test review. In the book review, if you guys notice, wait a minute, key, why would I, ooh, the odds and the evens, what am I doing? Why am I giving this to you?
So you can self-grade it after we're done.
Because I want you to do it, grade it, and come with all your questions at the beginning of class tomorrow. Well, after our forever quiz. Does that make sense? So you're busting them out, you're going quick, kind of like a test would be. You don't have tons of time on each question. Remember, the AP would give you 1.2 minutes each, approximately, on multiple choice. So yes, I've given you a lot of practice, but no directions. You don't even have to write the functions if you don't want to, because you probably won't be rewriting functions on your test when you take it either. And you're just trying to solve. And then the entire answer key is here. Now what would the foolish person do?
Copy.
Yeah. A, it would be foolish, and B, to be honest, I think it would take more time. But anyway, yeah, they would just copy it down. You have a test, and you're not going to be able to have an answer key for the test to copy from, right? Okay, so the smart person would just bust it out and then go grade it and come with all questions tomorrow. So this one's due tomorrow. We're going to spend the rest of class time basically working on it. However, did you guys notice there was one other thing in your Google Classroom? Ooh. Hey, I like bonus. Do you like bonus? Okay, so let's check out what this one says. This one is not from your book. This one is just like a PDF of practice multiple choice questions having to do with our chapter. And then there's some long answering ones using the definition of derivative or the difference quotient. And there's like a weird tricky one. That's kind of cool. So anyway, there's this whole thing, but what are the directions? There we go, set. Completing the attached chapter 1 practice test can add up to
3 bonus percent.
Every test is out of 100, so you can get 103, or you can go from a 67 to a 70, or a 58 to a 61, or just kidding, you won't be getting that.
No, you won't.
An 87 to a 90. If you've done the practice test. Now, warning, no credit will be given for
late.
Because what's the purpose of this practice test?
Before the test.
Yeah, to help you practice before the test, yeah?
Oh.
Now wait a minute, this is rough. I mean, we're going to take it and have no idea whether we got it right or wrong? Well, that's going to stink. What's after it?
Nothing.
My answer key with some of my work, not necessarily all my work, because some of them are kind of just quick plug and chug ones, but you do have the answer key right after it. Sound good? It's just stuck, I'm gonna. Okay. This one's due the day of the test by 8 a.m. So this one's due Thursday, whereas the other one is due tomorrow. Why? Because I want us to go over as many questions on the review as you guys have. I want them attempted by tomorrow. Does that make sense? Test review by tomorrow so we can go over questions, and then you have extra practice problems. If you're one of those that practices the way that you prepare for math, I gave you plenty, so you have some tonight and some tomorrow night. Are we good?
Yes.
So to that end, we're going to go ahead and I'm just going to give you work time on the test review after we go to our flip books one last time. Let's go to our flip books one last time. Okay, and as we do, let me go also to your test review. That way I can throw it up on the screen because a lot of you guys probably don't have your book. But you could go borrow one of my books and take pictures of it, and that way you have it for the rest of the day to work on. Some of you guys can do it in study halls, etc. But your flip book first. Didn't we have a page that we had to skip somewhere? Because we hadn't talked about, here we go, polynomials at infinity yet? But now we have. Okay. Polynomials at infinity. If you guys notice, this one has plus or minus infinity. This is a nice AP teacher who made this one. No, not me. I'm not this creative or have this much time. But going to positive or negative infinity is like beware. Who knows what they're going to give you. Now, they give you the algebraic way, which you might see in the answer key from time to time in homework, dividing by the numerator and denominator by the largest powers of x. This is a strategy. And when I let you guys start working on your review, giving everybody another opportunity if you want to come up and grab the books, etc., I will be available for homework questions. So some of you, there were some tricky ones for sure. So let's go ahead and do this one, number 5, the shortcut way with the degree test, but then let me show you how this whole crazy multiplying the top and the bottom by the largest power of 1 over x, how it works. But first of all, degree test for number 5, kiddos. Well, actually, if I were you, wouldn't you write in the shortcut? Just as a reminder, so we have our shortcut of the degree tests. But you guys see the example right there. What's the case? Top wins, bottom wins, or ties?
Tie.
Okay, so I have a tie between my negative 2x to the 5th and my 4x to the 5th. So wouldn't our hypothesis be that this would be a negative 1/2? Okay, let's double check we're right. To double check we're right, we would multiply the top and bottom by 1 over x to the highest power, which is x to the 5th. That's us identifying who is the champion and what their degree is. So then as we come down, we would do the limit as x goes to infinity, and we would need to distribute this piece by piece. Same thing down here, piece by piece. 7x squared over x to the 5th would be 7 over x cubed. These guys, the x to the 5th would just reduce. The next guy would be 5 over x to the 5th. On bottom we have 4 minus 6 over x cubed. Now the nice thing is when you do this strategy, the limit as I go to infinity of 1 over x to any odd power or 1 over x to any even power, thinking about our basic graphs, what this whole thing is talking about is saying, hey, no matter what you have, when you have a constant over x to a power, the limit to infinity will always be 0, whether you're going to the right or to the left, whether you're going to the right or to the left, whether you have even powers or odd powers. So the nice thing is every little piece, based on my basic rules, every little piece that has a denominator goes to 0. And what's left, cool kids? Negative 2 over 4, and negative 2 over 4 reduces to be, were we right?
Yes.
Yes. Yes, we were. But when does this get tricky? When does this get tricky? This would get tricky if you were to have something like the limit as x goes to negative infinity of 3x over the square root of 5 plus x squared. Well, in homework there were some ones where it was actually like a term plus or minus a square root, and rationalizing was the way to go, multiplying by the conjugate ultimately. Sorry, not rationalizing. Multiplying by the conjugate, but in this one, actually no. I'm just going to multiply top or bottom by 1 over the square root of x squared. Does anybody know why I'm doing the square root of x squared? That's kind of convoluted and awkward and weird. Oh, wait. I need this to be able to get inside, and the only way to get him inside is to put him under a square root. But technically, guys, what's true about these two? Aren't they? These two. Aren't they technically tied?
Yes.
So how does this math work? Well, on the bottom, it's not that big a deal, because on the bottom I can end up with the square root of 5 over x squared plus 1, because the x squared over x squared, 5 over x squared, it was allowed to come in because it had the square root. On top, though, it's this whole other version of awkward, because do you guys remember that the square root of x squared is absolute value of x, which is sometimes staying the same and sometimes being opposite depending on whether he's positive or whether he's negative, right? If this is true, I need to get rid of the square root of x squared because I need to simplify him with this dude, but who do I choose, positive x or negative x? Why negative, Adam? I'm dealing with negative values, so I need to put in a negative x. So technically, if you were very careful with the math, you wouldn't have to check the sign, because you would end up with a negative 3 naturally. But for me, I don't mind if you guys realize the degrees were tied, ratio of the leading coefficients, 3 over root 1, but check the sign. Would you have gotten the negative? Would you have plugged in, and would you have realized that plugging in gets you a negative over a positive, which is why you would need a negative 3. Does that make sense? Mm-hmm. The shortcut's there for a reason. It saves you a lot of time and a lot of work, but in homework, I know some of them, the only way to solve them was using this nasty technique, so I wanted you guys to be able to see it. Is that cool?
Yeah.
Okay. And technically, any college course would teach limits to infinity this way, and they might show you degree tests at the very, very end, but degree tests don't always work, so hence the dilemma. All right, I think our flip book is technically done, right? Okay.
Yeah.
I'm going to go ahead and zoom in on the beginning of your test review. If you guys want to take a picture of the screen, let's see. Where does your test review start?
5.
5, 13, 18, 20, 21, 23, 24. 5, 13, 18. Okay. Here we go.
Oh.
Or you can also borrow a book up here and take pictures of it. That's totally fine as well. You can pass it around once you get the pictures. Or you can come up here to the webcam and take pictures. I don't mind. Let me get over to where the light is a little bit more ideal. Oh, that's a bummer. Can I zoom out a little bit? Oh, but you guys need number 13 too. Struggle. There you go. If you guys want to take a picture and you can zoom in, that's totally fine. I'm going to freeze the screen, come up to the book, come grab a book. But as you do so, are there any homework problems you guys want me to get ready for you from last night, section 1.6? I can play with them on the whiteboards, or I can play with them in the video. Number 24 from last night. Anything else from number last night from homework last night? 24, 28. Anything else? 52. Anything else from section 1.6? Okay. You guys play with the review. You can grab a picture. That way you can zoom in and see what's going on. I think these ones are just solve the limit, right? I think those directions are just like plug and chug. Number 5 was weird because you have a graph. Number 5 was weird because you have a graph. Don't worry, like this review is still low stakes. You're not getting like a percentage grade on it, but treat it as much like a test as you can. Or if you do go looking to notes, etc., make a note of it with a colored pen with a highlighter being like, ooh, you did not remember this, brain, you better study it. You have to be strategic, and some of you in a way that you've never had to in a math class before. You need to be strategic. All right, let me play with what you guys have. Where's my phone? 24, 28, 53. I froze the screen. You guys can see it, yeah.
Misty.
Yeah.
I know you said don't show direction, but do you need to show like anything, or just do the work?
Well,
Graph.
just think. You're going to be grading these and getting them right or wrong. Think about when you're doing test corrections, if you just have like an A instead of a B and there's nothing to show your logic, I'm not sure how you're going to be able to correct the incorrect. So I would show as much as you can.